Next week, we will learn a rule called product rule, which helps us find a derivative of a product function, a function that can be written as something times something else. Today, we don't know it. So what we're going to have to do is we're going to first expand the expression using FOIL, and then we will just apply the power rule to those terms, okay? So let us FOIL this first, okay? So rewriting this f of x. First times first. 5x times 3x squared is 15x to the third power. Next, 5x times 1 is plus 5x. Next, 4 times 3x squared is 12x squared. And lastly, 4 times 1 is positive 4. So I first expanded the expression. Now I am ready to find the derivative of this function we call f prime of x using the power rule. Okay, you have 4 terms. You do them all separately. Okay, so starting with the very first, I'm going to multiply 3 times 15. 3 times 15 is 45. But the new exponent goes down from 3 to 2 because you always do original exponent minus 1. So we got the first term down. Next term, you have to do, well, that's just the 5x to the first power, right? So remember, we said when you are finding a derivative of a linear term, that's just going to be its coefficient. X goes away. Next, plus, I have to do 2 times 12, which is 24, and x will be raised to the first power because 2 minus 1 is 1, and the very last one. What is a derivative of a constant? It's always 0. So we don't have to put this green 0 or this exponent of 1. Okay, if you want to just simplify all the way. But that is how you can find the derivative of this product expression by first expanding it. Next week, I will show you how to do a power rule. I'm sorry, not power rule. I got confused. Product rule, where we don't have to expand it like this. But I think this one was super easy to just FOIL it out and do it. But if you have to do something like a trinomial times a trinomial, that means we're doing 9 different multiplications. So for that one, I think I would go with the other method. But for this one, I think this method worked beautifully. Okay, let me erase this 0 and let me erase this 1. Okay, otherwise this is just perfect. All right, a similar problem which we can do using a quotient rule because it is a quotient, but we don't know that yet. I never taught you quotient rule yet. So how do you find y prime if y prime is a quotient? So what I will do is I will divide each and every one of these by x to the 4th. So first, I will divide 2x to the 7th power by x to the 4th. I have x to the 7th over x to the 4th. That means I have 3 more x's on top. I'm going to get 2x to the 3rd power. All right, next. Oh, hold on. Let me copy down the minus sign. The next simplification or simplifying that I need to do is this. If I do 4x to the 6th power divided by x to the 4th, I will get 4x squared. All right, last one. Oh no, it's gonna be an ugly one. The last one, but you can't skip it. You have to still do it, okay? I have to do 9 over, not with the highlighter. I have to do 9 over x to the 4th. The first one and the second one are good looking terms. Last one is not good because the x to the 4th power is in the bottom. So what I will need to do is I will need to rewrite that. Keep the first one the same. Because what happened is when people do power rule too fast in their head, they take the derivative of the first two terms, but they forget to do, they just rewrite this. So what happened was these two terms will be ahead of the third, but they have to all go in the same speed, okay? Because later we'll take second derivative and third derivative, and like some people's answer will have like third derivative for the first terms, and then the first one is only at the second derivative. So if that happens, everything is all messed up. So just copy down 2x to the third minus 4x squared exactly the same. And then rewrite that plus 9 over x to the fourth as 9 times x to the what power? Negative fourth power. Listen, I haven't done any calculus yet until this point. All I did was simplifying that rational expression and rewriting so that all the terms have exponents. Why do they need to have exponents? Well, so that I can use my power rule. So here we go. Let's do calculus. Take the exponent and multiply by the coefficient. 2 times 3 is 6. Hold on, 6, and I will have x to the second power. Next, copy down that minus sign, but I need to do 4 times 2, which gives me 8, and x will get raised to the first power, right? Because 2 minus 1 is 1, but if it's an exponent of 1, I don't have to write it. Next, I need to multiply 9 times negative 4. Okay, that will give us negative 36. So that's why the sign changed to negative 36. And what should be the new exponent? Go down 1 from negative 4. Negative 4 minus 1 is negative 5. Therefore, this is the final answer. I guess I'm going to go ahead and circle this. This is the final answer. Okay. So I went over example 4 and 5 in this video. What is next? Ooh, example 6. Okay. I have time. Let me do example 6 with you. So this somewhat connects with what we talked about during class. We wrote an equation of a tangent line in class. Find an equation for the line. And remember what I told you. If you want to write an equation of a line, you need your x value, you need your y value, and you need your slope. And you're thinking, oh, this is crazy. How can I do all that derivative, or I'm sorry, the limit definition work, difference quotient work in this small room? See, we don't have to do that anymore because you know the power rule. So finding the slope will be super easy. But first of all, let me write down what they gave us first. So the equation is y equals 3x to the fourth minus 5x squared at a point 1, negative 2. Sometimes, guys, I make a mistake. So I'm going to double check if that point is truly on this curve. Okay, so let me try something. I'm going to check y equals 3x to the fourth minus 5x squared. And do I have a point really at 1, negative 2? I do have a point there. And what I did was I just picked any x value and I plugged in that x of 1 into the function. That's how I got the y value of negative 2. This is nice because I already gave you an x value of 1 and y value of negative 2 to start the problem. Well, I never gave you the slope though, so it's your job to find the slope. So let us find the slope by finding the derivative. Because why are we finding this derivative, right? That gives us the slope of a tangent line. That's why we are finding it. So find y prime. If y is equal to, let me copy this. Okay, let me make this a little bit bigger. If y is equal to 3x to the fourth power minus 5x squared, what is y prime? Well, we know our power rule. So let us use our power rule. 3 times 4 is 12. The new exponent is x to the third power minus 5 times 2 is 10, and the exponent goes down 1, so it's going to be x to the first power, which I will not write. So now what? To find the slope of a tangent line, plug in x equals 1 in here, okay? Oh, hold on. Let me move the work to the side a little bit. Oh, no. You want to come there too. Okay, that's perfect. Give me 1 second. My prime notation got erased. Okay, I'm all good. All right, I'm back. So let's find the slope. The slope is what we will get when we plug in 1 into that derivative function. And you know why we are plugging in 1, right? Because the given x value was 1. All right, if I do that, I think I'm looking at 12 minus 10, hopefully. If I'm wrong, guys, if I make any silly mistakes when I'm recording, please write me an email so that I can, fix it, right? Before everybody sees it. So the slope is 2. So I have all my numbers I need to write an equation of a line. I like to use my point slope form, which is y minus y1 equals m times x minus x1, and I will do y, well listen, I have to do y minus negative 2. That will turn into y plus 2 equals, the slope is 2 times x minus the x1 value of 1, and I'm done. I don't think it said put this in slope-intercept form. It never did. So my answer in point slope form is perfectly fine. So I will stop this problem right here. Okay? All right. I don't know, kind of an awkward point for me to stop because I only have 2 more examples to go over. So how about I keep on going? Okay, I'll finish this up. Okay, example 7, it's a slightly different problem. I really like it. I like to put this on your first test. It says find any point. Hey, hold on a second. I forgot to do something fun. I want to check if I get the answer, if I got the answer for example 6 right, by checking it graphically. So I remember I already graphed my function, the original quartic function, but what I will do is I will go ahead and graph my line. The line is y plus 2 equals 2 times x minus 1. And I use let me just use a green pen to sketch this tangent line and take a look how perfect. I can see that my line function is tangent. We have a point of tangency right here at 1, 2. And to me, it looks perfectly tangent. So that's how you can check it. Now, if you mess up and you see something like, I don't know, like you may see something like this. Like the line is not even touching that point that they talked about, then you know you did something wrong. So I think it's great if you have access to a graphing calculator, kind of check your equation of tangent line and see if it looks tangent to the graph, okay? Example 7. Find any point on the graph of f of x. Oh, it's a long function. What is this? What are we doing with this? So, okay, what about it? What about this function? At which a tangent line is horizontal. Oh, okay, a tangent line is horizontal. So graphically, let me see what we are talking about, okay? So horizontal tangent means a flat line, right? So if I have a graph 2 over 3x to the third plus 5 over 2x squared. Give me 1 second. Let me pause the recording just for 1 second. Okay, I came back. So I was going to graph this function to show you, I don't know, what are they talking about? So minus 3x plus 7. So I have my function graphed, and what they are looking for is a point, some point on this graph. Let me see, where is the graph, by the way? There is the graph right there. So, and you guys don't have to graph this. I just want to graph it because I want to see a picture. So this looks good. I'll just mess with the scale a little bit so that it shows you the picture. So, all right, this is what it looks like. And what they are asking is, at what point do we have a horizontal tangent? And I can see it already. We're going to have a horizontal tangent at a local maximum or local minimum, okay? So the answer will be, what if I can only read I think the answer will be at 0.5, the x value of 0.5, because that is the local minimum, and the x value of this one, I think the value will be at -3. So x equals -3, x equals 0.5 is the answer, because if I sketch a horizontal tangent, take a look, what's the y value? 20.5. Y equals 20.5. Do you believe me if I say this green line is a tangent line at -3, right? This touches that point at exactly 1 point here. And I have another tangent line down here at y equals 6.208. 6.208. And let me use a dotted line. If I zoom in, do you believe that this point, this purple line right there is a tangent line to the curve at this point right there, right? So I know the answer already graphically, but how do we find this? How do we find this? And I never really show my other sections, like the graphical way of doing this, but I thought maybe I can start with that this semester. All right, find any point on the graph of this function at which tangent line is horizontal. So I want you to write down something for me. Horizontal lines have slope of what? 0. If it's the horizontal line, the slope must be 0. So what we are doing is find f prime of x and set it equal to 0 and solve for x. That is how you can solve this problem, okay? Because horizontal lines have a slope of 0, and we know how to find the slope of a tangent line, we find the derivative. Set that derivative equal to 0, and if you solve for the x values that will make that true, then we can answer this question. So what we need, what do we need? We need to find the derivative. So if the function is, let me copy this down, okay? I'll copy this down here so that I can look at it. If the function is like this, the f prime will be, I need to use the power rule, right? 3 times 2/3. 3 times 2/3 will be 2. And I'll get 2x squared, right? Because I have to go down 1. Next, I need to do 5/2 times 2. 5/2 times 2 is 5, and that will be raised to the x to the first power, so I don't have to write that. Next, derivative of -3x is simply -3. And derivative of 7 is what? 0, so I don't have to write that. So what we got is that the derivative is a quadratic function. Now, set this equal to 0, okay? Set this equal to 0 and solve for x. I need more room to do that, right? So let me add a page after it. Add a page after it. And I'll copy this down, okay? That's my plan. Okay. Right, so 0 equals 2x squared plus 5x minus 3. I get to check out your factoring skills. So let me factor this into 2 trinomials. I can try 2x and x. And let me try 3 and 1. I may be wrong, but this is my first guess. But how lucky will I be? Let me take a look. If I FOIL this, I'll get 2x squared. That will give me minus 2x. This will give me plus 3x. This will give me minus 3. But if I combine these two, I will get positive 1x. And that's not positive 5x. So this was incorrect factoring. So let me try something else. I'm using guess and check method. You have different method that you learned. Use that method, okay? I'm going to try to just do this by guess and check. How about I change the numbers here? Let me make this one 1, and let me make this one 3, and I'll try again. 2x times x is 2x squared. If I do 2x times negative 3, that will be minus 6x. If I do 1 times x, that is positive 1x. And lastly, this will be minus 3. Oh, I think I'm getting closer here. This is negative 5x. So at least I got the number matching. But if I want this negative 5x to be a positive 5x, that tells me that 1 has to be negative and the 3 has to be positive. All right, I did this by guess and check. So I got my factor. I got my trinomial all factored. I used to teach AC method, slide and divide. So if you want to use that, that's okay too. Okay, but this is just, works fine. You know, some of you use different factoring style. All right, I'm going to go ahead and set each of these equal to 0. 2x minus 1 equals 0. 2x equals 1. X must be half. So the first answer is x equals half. When x is equal to half, we will have a tangent line that is horizontal, whose slope is 0. When is x plus 3 equal to 0? That happens when x is equal to negative 3. So when x is negative 3, the tangent line will be horizontal, whose slope is 0. And was that right graphically? So two answers that I got algebraically is negative 3 and 1/2. If I click on, or if I click up, or hold on, x equals 1. Oh, no. What am I doing? I'm sorry. Or I guess I can just plot a point. Yeah. At negative 3, that's where we have this local maximum. And down here at 0.5, if you can see, let me see, 0.5, which is half, that's where we have the local minimum. And then those places, the tangent line will have a slope of 0. And those places, we will have a horizontal tangent. So I hope this makes sense. Okay, that was example 7, and we'll do similar problems again because I think this one was a little bit more difficult. All right, let me do the very last application problem, and that will be it for this week's asynchronous lesson. Akemi drives all afternoon to visit her family. Her distance traveled in miles, t hours after starting out, is given by f of t equals 1.85 t cubed. Okay, all right, it's a cubic function, okay? Now, so what's happening? So they said t is number of hours. What I'm seeing is that t is restricted. T starts from 0 hours, right? Because if she didn't start her journey or drive yet, T must be 0 hours. She's home. But how long is her trip? I think she got there at after 5 hours because T only goes up to 5. So T, the number of hours she drove, is in between 0 to 5. Okay. Find the distance Akemi has traveled at t equals 3 hours. Well, this one is easy because look, her distance traveled after starting is by given this function. So if we have the distance function, this is the distance function. So all you need to do to find the distance is plug in 3 into this function. Okay, after 3 hours, how many miles did she drive? Okay, 1.85 3 cubed minus 18.175 3 squared plus 82.51 times 3. They gave us the distance function and they asked us, what's the distance? Then we just have to plug it in. I'm going to go and open up my calculator. 1.85 3 cubed minus 18.175 3 squared plus 82.5 times 3. She drove 133.875 miles. Okay, after she left her house, drove for 3 hours. That's how much she drove. So if I just out of curiosity, how fast was she driving? Let me take a look. 133.875 divided by 3. She was going 44.625 miles per hour. That's kind of slow, I think, on average. Okay, all right. Now what? Now the second part is asking for the calculus question. Find the instantaneous rate of change, her velocity. Okay, speed with the direction. So that's the derivative, okay? So what you have to do, if they're asking you to find the instantaneous rate of change, this is a slope of a tangent line, okay? What you have to do is first find f, well, I don't have to say first, find f prime of 3. Find the derivative function and plug in t equals 3, okay? So that's how you find the velocity, okay? Whenever you need to find the velocity, find the derivative and plug in whatever that number is. For acceleration, you're going to find the second derivative, but that's for 1.8. That's for later. So let us find the derivative. Okay, let me copy down this function. Copy. All right, I'm ready to do the derivative. So using the power rule, what is f prime of t? I need to multiply 3 times 1.85. Okay, guys, I'm gonna need some calculator for this. All right, 1.85 times 3. That is 5.55 t squared. Next, I need to do this decimal times 2. 18.175 times 2. That is 36.35 t. And the last one is just a linear term. It's 82.51 t. So the derivative will be just plus 82.51. For linear terms, the t just goes away. Okay, all right. Now let's plug in her time. At 3 hours, how fast was I going? Oh, and I better go fast. I only have 5% left on my Apple Pencil, but it's good. This is my last one. So 5.55 times 3 squared minus 36.35 times 3, and I just have to add 82.51. All right, I'm going to go ahead and type this in the calculator. 5.55 times 3 squared minus 36.35 times 3 plus 82.51. That comes out to be 23.41. Let's put the unit though. This is our speed. This is our speed. Miles per hour. So 3 hours after she left her house, she was driving 23.41 miles per hour. But quickly checking that her average was, well, I don't think I want to go there right now because I may be saying the wrong thing if I didn't think about it too carefully. But that is how you can find the distance traveled by just plugging it into the distance function they gave you. But if they ask you for the instantaneous rate of change, her velocity, her speed, we have to find the derivative function and then plug it in. Okay? All right, and that is it for lesson 1.5. Next week, when you come back, I will teach you how to do a product rule in class. Okay?